Laced within the cold, desolate swaths of the space between stars, lie myriad orphaned planets not tethered to a particular system. They are lost worlds floating in the darkness of interstellar space, and there are likely tens of billions in the Milky Way galaxy alone. Some may resemble our neighboring worlds, rocky exoplanets and gas giants that were ejected from their neighborhoods by chaotic gravitational encounters. Others, meanwhile, are more like failed stars, which were unable to attract enough mass to ignite a nuclear furnace. We've known of these mysterious, shadowy worlds for many decades now, but due to their sheer distance, dimness, and absolute minimality on the black background of space, only a handful of such objects have ever been identified. But thanks to the unparalleled brilliance of the James Webb Telescope, alongside a host of sensitive survey satellites, we're finally unraveling the mysteries surrounding the nature of starless planets, uncovering seismic revelations along the way that have left scientists stunned. Such is the topic of our video today, as we journey through the Milky Way galaxy in search of lost worlds in the darkness of interstellar space and sometimes even intergalactic space. A rogue planet is a world that does not follow a parent star like the Sun, and instead orbits the core of the Milky Way galaxy, barreling through interstellar space at breakneck speeds for hundreds of millions of years on end. These worlds usually start out in environments analogous to the young solar system, but become ejected from their neighborhood by a tussle of contrasting gravitational influences. Most of the time, this is due to the gravity of a tremendous Jupiter-mass planetary core sweeping through a young system in the early stages of formation, dispelling the lesser bodies in its wake with the whiplash effect of its gravity. This slingshots those smaller bodies and sends them careening towards the fringes of their planetary system, where they resettle into highly unstable elliptical orbits, if not banished from the system altogether. Alternatively, the gravitational whiplash from a passing star may disrupt the relatively settled, stable orbits of exoplanets, sending them spiraling into space, especially if passing directly through a system's plane. One way or another, these worlds all share the same destination: the freezing, void-like expanse of interstellar space, lying far beyond the warmth of any particular star. Out here, temperatures plummet to just a few kelvins above absolute zero, cold enough to freeze the very atmospheres of rocky planets like Earth, sending their molecules snowing down to the surface into dusty deserts, atop thick, solid layers of frozen seawater and bedrock. When a planet goes rogue, it races out of its system at mind-bending velocities. For comparison, stars like the Sun orbit the Milky Way's core at speeds of about 220 kilometers per second, relative to its center of mass. Rogue stars, meanwhile, dislodged from clusters and multi-star aggregations, can stream through space at up to 670 kilometers per second. But rogue planets are orders of magnitude smaller and less massive than stars, and are thus much lighter, and travel faster across space when catalyzed by gravity. Ejection from a system by a Jupiter-sized object might accelerate a rogue planet to upwards of 200 kilometers per second. But the fastest, so-called runaway rogue planets, ejected by the messiest gravitational encounters, may be pinballed into the wilderness at more than 1,000 kilometers every single second, equivalent to several million miles an hour. Such speeds lie well in excess of the 600 kilometers per second velocity required to escape the gravity of the Milky Way. And while we've never seen a rogue planet at such vast distances, we have observed instances of hypervelocity stars on trajectories that leave the galaxy. As such, it stands to reason that around the rims of a galaxy, where the gravitational influence is generally weaker, a sufficiently torrid event like a merger with another galaxy may eject outlying planets with enough force that they break free from the Milky Way's grasp altogether, hurtling into the abyss of intergalactic space. Any journey into this void would redefine its observer's perspective on darkness and loneliness. Without even the faint light of surrounding stars to illuminate the dim sky, temperatures out here scarcely rise above the baseline of space itself, with only a dozen or so atoms scattered across every cubic meter of space. Inside the galaxy, going rogue is not necessarily a life sentence for an ejected planet, as it could later become entrapped within the gravitational web of a binary or triple star system, pulling it into a chaotic, wide-angled orbit around a new host. But in intergalactic space, there's no such prospect. No signals could ever reach you, or anyone you knew back home, in any meaningful period of time. And you'd be far too distant, dim and diffused into the backdrop of space, to ever have a hope of being found, by any conceivable human technology at least. All you would know is cavernous void of the space between galaxies, trapped in its incomparable enormity and inescapable darkness for billions of years on end. Rogue planets ejected from their system of origin account for just one type of starless world floating in the darkness of space. The other, probably more abundant type, is a world that never knows the light of a parent star, as they themselves are a failed star, which was unable to accrue the 80 Jupiter masses needed to ignite a fusion furnace. Below this threshold, a stellar seed will deteriorate into a brown dwarf, a small, faint, and dim miniature red star, which glows via the fusion of deuterium isotopes, not hydrogen nuclei, as required by a conventional star's furnace. However, if a particularly meager attempt at forming a star fails to accumulate even 13 times the mass of Jupiter, then it will not be able to sustain fusion of any kind. Rather, the substellar seed will evolve instead into a particularly massive, hot and puffy type of gas supergiant known as a sub-brown dwarf. The plains of the Milky Way galaxy are littered with the shells of these would-be stars. Sub-brown dwarfs are thought to account for the majority of free-floating planets, including the few dozen candidates we've managed to identify, like PSOJ 318.5-22, a super Jupiter-sized sub-brown dwarf discovered in 2013. In the years since, we've identified a number of additional candidates from a wide variety of telescopes and datasets. But it is the unrivaled clarity offered by the James Webb telescope that has blown this mystery wide open in only the last few years, finding hundreds of free-floating, starless planetary mass objects in the Orion Nebula, whose existence appears to defy conventional models. As we've established, there are two main types of free-floating planet. One, which is a failed star, and the other, which is an orphaned world. For many decades, these were the two distinct types to which all the galaxy's starless planets were thought to belong. But in 2023, Webb primed its sensitive NIRCam instrument to probe near the heart of the Orion Nebula, utilizing its ability to peer through dust and gas to glimpse the stellar seeds lurking within. But what it found was completely unexpected. A slew of more than 500 free-floating planetary mass objects ranging between half the mass of Jupiter and 13 times its mass, the threshold for deuterium fusion. And of these round about 550 objects, some 42 of them appear to be orbiting in binary systems mimicking the behavior of stars. As such, they've come to be known as jumbos, Jupiter mass binary objects, and their existence poses a significant challenge to our contemporary understanding of the planet-forming process. According to current theories, most of these objects are far too small to have formed like stars from the collapse of a gas cloud. But that would imply almost all 550 must have started out elsewhere, within the disks of nearby stars, before being ejected and somehow winding up deeper within the nebula. It's quite an improbable scenario, as we would not expect to see the delicate dynamics of so many binary systems preserved during such an ejection event. And so, one idea is that Webb has stumbled upon a new type of planetary formation pathway, whereby the radiation from massive, inhospitable surrounding stars carved out clumps of ionized gas in regions near the core of the nebula, which fragmented and eventually collapsed to form pairs of planetary mass objects. No parent stars or circumstellar disks required. Either way, it underscores the notion that starless worlds may be as populous in the galaxy as planets like our own, and they come in a broader range of sizes and types than we ever could have imagined. Not just those ejected orphaned worlds whizzing round the galactic center, but also substellar seeds tucked away in thick, opaque pockets of nebulae, and almost every other corner of the Milky Way where stars and planets can be formed. In recent years, we've uncovered scores of these sub-brown dwarf and failed star candidates, but it's a different story when it comes to rogue planets, which are simply too small and dim against the backdrop of space to have realistic chance of detection. We can hardly even identify worlds still barely clinging on to the outskirts of our own solar system, in regions dozens of times further than Neptune. Out here, we stray into bands and belts containing trillions of shepherded icy and cometary chunks, known as trans-Neptunian objects. These objects tend to traverse the solar system in orbits that become increasingly offset, elliptical and one-sided the further from the sun they lie. One such object, with one of the widest known circumstellar orbits, is Sedna, a so-called extreme trans-Neptunian object. Sedna is a small, scrappy dwarf planet lying about 84 astronomical units, or 12.6 billion kilometers from the Sun. It is currently closing in on its perihelion, the closest approach to the Sun along its orbital path, which still lies a hefty 76 astronomical units distant, 2.5 times further than Neptune. So far out, the Sun would appear as a mere whisper of light in Sedna's dimly lit sky, less than half the size and strength of the full moon viewed from Earth. And yet, it is reduced to nothing more than a luminous pinprick at the point of the dwarf planet's aphelion, that is the furthest it wanders on its journey. The far side of its asymmetric, offset path around the Sun takes it a whopping 930 astronomical units distant, almost 1,000 times further than the Earth, and 20 times the average distance of Pluto, by far the widest orbit of a solar system satellite that had been discovered at the time. It was first picked up in 2003 by a team of influential scientists at Palomar Observatory in California, who sought to identify massive trans-Neptunian objects with very large orbits and perihelia. Among them was the self-described killer of Pluto, Professor Michael Brown, of the California Institute of Technology. In the years that followed Sedna's discovery, he helped identify dozens of additional remote, Pluto-like icy bodies belonging to the Kuiper Belt, which threatened to overrun the solar system's planetary classification by diluting it with a plethora of indistinct minor worlds. And so, in 2006, the International Astronomical Union voted to reclassify the definition of a planet to a body which clears its orbital path, effectively excluding members of the Kuiper Belt, like Pluto, from being planets. As such, the solar neighborhood's esteemed ninth member for almost a century was struck off, bringing its total number of recognized planets down to 8. But speculation over a more substantial true ninth planet, lying well beyond the recesses of the Kuiper Belt, has been rumbling ever since the discovery of Neptune itself. But over the last decade, that speculation has intensified, courtesy of Pluto killer Mike Brown and another of his former colleagues, Professor Chad Trujillo of the University of Northern Arizona, credited in the discovery of more than 50 minor planetary bodies. Approaching a decade on from Sedna's discovery, he would uncover a handful of similar-sized bodies with extreme orbits around the Sun, like 2012 VP-113, which stripped Sedna of its long-held record for the most distant known perihelion in 2012. And just 2 years later, Trujillo, alongside another colleague, Dr. Scott Shepard, had identified no less than 12 extreme trans-Neptunian objects, each with a peculiar shared characteristic. Though homing in on the Sun from a variety of different angles, inclinations, and directions, each of these dozen ETNOs appears to make its closest approach around the same spatial region, such that if you were to draw lines from the Sun to these perihelion points, they would all roughly converge around the same sector of space. But we would not expect such objects' orbits to be physically aligned. They arrive from such enormous and contrasting angles that all sorts of stray influences should randomize the distribution of their perihelia. And yet, their apparent clustering teases the signature of gravitational shepherding. The objects are being influenced by a massive, unseen body lying considerably beyond the perimeter of the known planetary neighborhood. In a 2014 paper, Trujillo and Shepard postulated this object to be an undiscovered super-Earth-type rocky planet, at least 200 astronomical units from the Sun. With a mass thought to be several times that of our own world, its gravity would be sufficient to induce a noticeable effect on these extreme offset TNOs. But neither scientist was to be drawn on speculation over the prospect of a new ninth planet. It wasn't until 2 years later, in 2016, that Trujillo's former colleague turned Pluto killer Mike Brown whittled the former's list down by half to just 6 ETNOs and modeled their orbits as being influenced by a considerably larger Neptune-like giant planet on the fringes of the solar neighborhood, which has come to be nicknamed Planet 9. Planet 9 is described in a paper by Mike Brown and Konstantin Batygin to be an ice giant with similarities to Uranus and Neptune, such as an iron core, surrounded by a mantle of magnesium silicate, topped by various layers of hydrogen, helium, and icy volatiles. In the order of about 10 times the mass of the Earth and anywhere between 3 and 5 times its diameter, this lost planet's gravity appears to dominate the outer reaches of the solar system, responsible for shepherding the most remote ETNOs, just as Neptune tends the Kuiper Belt and scattered disk. But even at its closest to the Sun, Planet 9 would still lie more than 10 times Neptune's distance, while the far side of its highly elliptical orbit may take it more than 1,000 astronomical units beyond. Furthermore, This orbit lies considerably out of sync with the solar system's ecliptic plane, the roughly flat circular imaginary tabletop, upon which most of the other planets make their laps around the Sun. According to Brown and Badigan, Planet 9 lies some 30 degrees out of alignment with this plane, which they argued could explain the high inclinations of shepherded objects like Sedna. They also attributed this slant to another of the solar system's unexplained characteristics, the tilt of the ecliptic plane itself, which lies some 7.25 degrees out of sync with the Sun's axis of rotation. In 2019, Mike Brown postulated this tilt to also be the result of the hypothetical Planet 9, exerting a twisting influence from above the ecliptic plane that forces the other planets' orbits to yield slightly to reach a stable equilibrium. However, critics of this hypothesis have since argued that, even at the upper bounds of the 17 Earth mass range postulated for Planet 9, this would only be enough to induce a negligible tilt of less than 1 degree on the ecliptic plane. And so, the mysterious source, the solar system's apparent tilt, remains at large. In any case, however, the question is the same. What is it doing so far away and off balance compared with the rest of the planetary neighborhood? One thing's for sure, Planet 9 almost certainly wouldn't have formed in the position we may find it today. There's no way the circumstellar cloud that birthed the solar system's contents could have reached so far out. On the contrary, Planet 9 probably formed in a much more promising position inside the young solar system, but became caught up in an encounter which booted it from its neighborhood. 4.5 billion years ago, this world would have been nothing more than a wandering planetary core, sweeping round the torrid vortex of the young solar system and clearing vast trails in its primordial dust, gas, and volatiles. But it shared this environment with another of the solar system's prized planets, Jupiter, the oldest and largest world left standing today. In the earliest instances of their formations, these two giant cores may have found themselves pitted against one another in a race to attain gas giant stature. Evidently, it was Jupiter who triumphed among all other suitors in this race, 2.5 times the mass of all the other planets combined. As such, it may have been an encounter with the godfather planet's gravity itself that disrupted Planet 9's development, curtailing its feeding and slingshotting it on a trajectory towards the cold outer rims of the young solar system, where it accrued the remainder of the volatiles, rendering it an ice giant. The renegade planet may have been on a path to leaving the solar system altogether, but was apparently interrupted between 100 and 200 astronomical units from the Sun as it began to twist off course and out of alignment with the ecliptic plane. This may be because the planet plowed head-on into a belt of icy planetesimals, with dynamical friction slowing, but not stopping the planet's outward drift. Alternatively, it may have been the gravity of a nearby star that induced this disorienting twist. After all, the solar system is believed to have formed as just one member of a vast open cluster of between 200 and 400 stars, each less than a light-year apart from one another at their inception. Gravitational interactions between members may have given Planet 9 its final kick towards the periphery of the solar neighborhood, or it might even have been captured in orbit by the Sun after being ejected from another slightly older star in the cluster. While the chances of us inheriting an extrasolar rogue planet from a near neighbor are exceptionally slim, they rise to a more statistically significant 1/5 if the Sun was born in a binary system that has since disbanded, as is the norm for most Sun-like stars. However, if this is the case, then it would likely render Planet 9 nothing more than a temporary visitor to our solar system, and not a true permanent resident, with its chaotically unstable, winding orbit soon slingshotting the world back towards interstellar space, where it will wander in isolation once more for millions of years to come. Until we find this elusive world, all the exotic and fascinating ideas surrounding a ninth planet remain purely unproven conjecture, a cloud that only its direct, inarguable detection can chase away. Back in 2018, scientists were bullish over the prospect of several converging lines of evidence rendering Planet 9's detection only a matter of time. But approaching a decade since Brown and Batigan's original publication, we're still no closer to its discovery, with few eyebrow-raising revelations or watershed moments along the way. As a result, public enthusiasm in the mystery has somewhat faded, especially in the wake of more exciting movements around worlds beyond the solar system, like K218b. The problem for Planet 9 is that, even if it does exist, we've no idea where, as it is far too small and remote to reflect a meaningful quantity of the scarce sunlight it receives, effectively ruling out instruments that probe visible light from aiding the search. Instead, we have to use infrared wavelengths, which are considerably more effective in revealing the ghostly echoes of space's hidden treasures. Most objects cooler than stars emit radiation most prominently in infrared wavelengths, but the juiciest details are notoriously hard to pin down even with advanced technology. At the time of Planet Nine's conceptualization in 2014, only a handful of telescopes boasted both the sensitivity and depth of field to have any hope of turning up such a dim, far-off world in their datasets. One of them was NASA's Wide Field Infrared Survey Explorer, aka WISE, and another, the ground-based Pan-STARRS mission in Hawaii, but neither identified any compelling candidates. We now, of course, have the James Webb Telescope breaking down infrared barriers, but the problem with using Webb for this task is that it is not a survey telescope capable of searching a wide area. At any given moment, Webb's view of the cosmos is less than the area of a grain of rice overlaid on the night sky, which makes using it to search empty space an extraordinarily inefficient use of the telescope's resources. It is only when a candidate is identified in the dataset of a wide-field survey telescope that Webb will be able to offer any further clarity in the search for this elusive world. But there is cause for optimism of late, because as recently as 2025, a tentative new candidate source with properties matching some we'd expect of Planet 9 was plucked from the infrared sky by a PhD researcher at the Taiwanese National Tsinghua University, Terry Fan. He delved into the extensive data collected by NASA's Infrared Astronomical Satellite, launched in 1983, and compared it to the dataset of Japan's Akari infrared spacecraft, launched 2006. Given the 23 years elapsing between the start of the two missions, it was anticipated that any candidate source would have shifted slightly between the two datasets, reflecting the planet's slow, wide-angled trudge across the sky. Fan designed software to sift through and compare these catalogs, returning a list of 13 tentative sources with matching properties. He then independently scrutinized each source, refining his list to just one candidate in the constellation Eridanus. Its shadowy outline resembles the fingerprint of an intermediate-sized gas giant planet, at least 250 astronomical units from the Sun, which has moved about 47.5 arc-minutes between the two surveys, or 1.5 times the width of the full moon on the sky. As such, it made for a promising new candidate, but several questions have since been raised over its legitimacy, and due to its sheer distance and the timescales involved in tracking its movement, it's impossible to know for now whether this source is a true satellite of the Sun. In fact, critics point to our difficulty in tracking the paths of TNOs accurately as a major source of bias that has us chasing shadows in the outer solar system. But regardless, the search for Planet 9 is far from over, as next up to sample the infrared sky will be the revolutionary Vera C. Rubin Observatory, a survey telescope with an unparalleled deep, sharp, and most importantly wide view of the cosmos, which will surely unearth a host of currently unseen infrared sources that may one day bring us closer to the truth. Until then, however, we continue our search for the solar system's elusive ninth planet, truly a lost world in the dark. And with that, I bid you good night. C signing out.